Okay, video number 4. Page number no 5. Video 5, page 5. Um, Question 46. I can't believe I made this so long. I'm a monster. So a population numbers 11,000 organisms initially and grows by 8.5% a year. Write an exponential model for the population. So our population is going to be equal to our initial amount, so 11,000 organisms, times 1 plus whatever our rate is, so that's 8.5%, so it's going to be 0.085 to the power of t, which is our time in years. So what's the population after 4 years? So that is 11,000. We can call this like P of t. So we want to find P of 4. 11,000, 1.085 to the 4th power. Again, I don't have my calculator on me, so you just punch that in and then round to the nearest whole number. And I'll have that question answered for you in class. How long will it take for the population to double? So if it's doubling, that means that P of t is equal to 22,000. So 22,000 is equal to 11,000 times 1.085 to the t power. And so we got to get t by itself, but it's up there in the power. So we're going to start by dividing both sides by 11,000. Which should give us 2 is equal to 1.085 t. And then we're going to take the log, and this sounds really weird, but the log base 1.085 of both sides. That way we can cancel out that base. So that would leave just t is equal to log base 1.085 of 2, which is about something, and I'll have that answer for you in class. Punch that in the calculator, should give you the answer. A car was valued at $38,000 in the year 2003. It depreciated to 11,000 by the year 2009. So what is the value of the car's depreciation? So in this case, so that goes from 2003 to 2009. So let's write our function. So the value over time, so v of t, is equal to 38,000. 38,000. We don't know its depreciation value, so we're gonna do 1 plus 1 minus, sorry, 1 minus. We'll call it lowercase p for percentage, or we can call it r. That's probably a better word, better letter. R for rate, the rate of depreciation, to the t. So that is our equation there. We don't know r, we don't know t, we don't know v of t. So by what percentage of the car value depreciating? So its value, so this is telling us that v of t is equal to 11,000 And t is equal to, so that is 6 years. 2009 minus 2003, that is 6 years. So we have 11,000 is equal to 38,000. One minus r to the sixth power. So we can start by dividing both sides by 38,000. So when I divide by 38,000 over here, all these zeros cancel out, leave me with 11 over 38 is equal to 1 minus r, oops, not 1 minus 6, 1 minus r to the sixth power. Then I take the sixth root of both sides, which just sounds weird, but the sixth root of both sides. I'm going to move that over here. So I get the sixth root of 11 over 38 is equal to 1 minus r, not 6, why do I keep writing 6? 1 minus r. We can subtract 1 from both sides. Actually, we can just add r to both sides. Let's do it this way. We're going to add r to both sides to get the negative away from r. And then we'll subtract this giant monstrosity from both sides as well to move it over to that side. So that's going to give us r is equal to the cube root, sorry, the sixth root of 11 over 38. Nope, scratch that. R equals 1 minus the sixth root of 11 over 38. And so r is going to be about something. I don't know. I'll get a calculator and I'll take a look at it. What will be the value in the year 2013? So that is when t is equal to 10. In that case, we just plug all this in. The value of the car, the value of the car after 10 years, so v of 10, is equal to 38,000 times 1 minus, and then we got to figure out what our r is and plug it in. To the 10th power. I know my r, so if you want to know, my r is equal to 1 minus all that, so I can actually plug all of that in to leave myself enough room. Let's do this. See, this is why I don't write in pen. 1 minus 1. That's the square root, sorry, the sixth root of 11 over 38. To the 10th power. So, yep. That's composition of functions, by the way. I know, tie in. Find one thing, plug it into another, composition of functions. And plug that in your calculator, and we'll see what we get. Okay, which brings us to compositions of functions. Yay! So we need to find f of g of x and g of f of x for each of these. So f of g of x. Am I still in frame? Just barely. Is equal to, so we're going to take all of g, taking all of g and plugging it in right there. So f is equal to 1 over, and then I got a big x right there, minus 4. And so we'll, wherever this x is, we're going to plug in g. 2 over x plus 4. We don't need the parentheses, so those 4's cancel out, leaving us with 1 over 2 over x, which we just use our, fraction and fraction rules to give us x over 2. So f of g of x is equal to x over 2. Switching it around, g of f of x. So now we're taking all of f of x and plugging it into g. Draw a little dividing line here. So we're taking all of f of x now, and we're going to plug it into g of x. So this whole bit goes right there where that 1x is. So g is 2 over x, and then plus 4 is outside of the fraction. So in here I have 1 over x minus 4. So we use the same fraction rules that we had before, and keep change flip, and we get 2 times x minus 4 over 1 plus 4. So we don't need the 1. This becomes 2x minus 8. 2x minus 8 plus 4. And then collect our like terms. And so our final answer ends up being 2x minus 4. So g of f of x is equal to 2x minus 4. Okay, one more problem on this page. So we have f of x is equal to x, the square root of x plus 2, and g of x equal to x squared plus 3. So we're going to find f of g of x, which is equal to, so we're going to take all of this. So first we're going to start writing f of x first. And instead of writing x, I'm going to plug in all of g of x. X squared plus 3. And then we'll have plus 2 on the outside here. It is outside the radical. So this is going to be a very unsatisfying answer because we have two terms in our radical. Two terms in our radical. And there's not much you can do with that. I know, quite unsatisfying. If this was like, a perfect square, that'd be nice, but it's not. It's not. So we just get x squared plus the square root of x squared plus 3 plus 2. And that's it. That's it for that one. So let's see here. We get g of f of x is equal to, so g is x squared, so we're going to open up parentheses, square it, and then add a 3 on the outside, and then plug in our f of x here, which is the square root of x plus 2. Now, if you want, you can binomial expand that. You don't have to. I'm not looking for the expansion. So our final answer will just be the square root of x plus 3 squared plus 2. No, plus, well, oh, wait a minute. This should be square root of x plus 2 squared plus 3. There we go. And that concludes video 5.